Imagine a world where machines don't just follow instructions, but actually learn from experience. A world where your devices can improve their performance, understand your preferences, and even predict what you might do next. That world isn't science fiction, it's happening now. And at the core of it all is something called machine learning. Today, you'll dive into this fascinating concept that powers everything from Netflix recommendations to self-driving cars. Don't worry if it sounds complicated, we're going to make it simple, practical, and surprisingly intuitive. Let's begin by clearing the biggest misconception. Machine learning is not magic. It's math and data. But instead of hard-coded rules, it's about writing algorithms that improve automatically through experience. Think of it like this. If traditional programming is like writing a recipe that must be followed step by step, machine learning is like training a chef who learns how to cook better each time they make a dish. You don't tell the chef what temperature to use or how many minutes to wait, you just let them experiment, taste, and improve over time. So how do we train machines? It starts with data, lots of it. Machines need examples to learn. If you want a computer to recognize cats in photos, you don't explain what a cat looks like. Instead, you show it thousands of images labeled as cat or not cat. The machine uses this labeled data to find patterns. Perhaps it notices cats have pointy ears, small noses, or a certain texture of fur. This process is known as supervised learning. In supervised learning, the idea is simple. You feed the machine input data along with the correct output. It's like having a student learn with a book full of questions and answers. Over time, the machine creates a model, a set of rules or relationships that best connects inputs to outputs. Once the model is trained, you test it by giving it new, unseen data. If it gets the right answer, great. If not, you go back and tweak the model. Let's say you want to predict the price of a house. You feed the model data from thousands of homes, square footage, number of bedrooms, neighborhood, age, and the actual selling price. This is your training data. The model learns how these features influence the price. Later, when someone wants to estimate their home's value, you plug in the details and the model gives a predicted price. That's supervised learning in action. Now, what if you don't have labeled data? That's where unsupervised learning comes in. Instead of giving the machine questions and answers, you just give it raw data and ask it to find structure. Imagine dumping a bag of colorful marbles on a table and asking a robot to sort them. You never told it what a color is or how to group them, but the robot figures it out anyway. It starts clustering marbles into groups based on similar characteristics, maybe by color, size, or texture. That's what unsupervised learning does. A real-world example. Think about marketing. Suppose you run an online store and you want to segment your customers based on behavior. You don't know who's a loyal beer or who just browses. But if you feed the model customer data, things like time spent on the site, number of purchases, browsing habits, the machine might find natural groupings, frequent buyers, window shoppers, or first-time visitors. This helps you target ads or promotions more effectively. Another example. Imagine a machine learning model analyzing thousands of songs on Spotify. Without knowing the genre or artist, it might still group songs based on tempo, pitch, rhythm, or instruments used. Later, it could suggest music you'll like, even if you've never heard it before. That's unsupervised learning quietly shaping your playlists. But machine learning doesn't end with just supervised and unsupervised. There's also reinforcement learning, a fascinating branch where machines learn through trial and error. Picture a game-playing AI that starts off clueless. It doesn't know the rules, but every time it wins or loses, it gets a reward or punishment. Over thousands of games, it learns strategies that maximize wins and minimize losses. This is how AI is like AlphaGo beat human champions. However, reinforcement learning is a bit more advanced, and we'll explore it in a future lesson. For now, let's get comfortable with a few key terms you'll hear again and again. First, training. Training is when the model learns from data. You feed it examples, and it adjusts its internal parameters to get better. Imagine a sculptor carving a statue. With every chip, the figure becomes clearer. The model does something similar, refining itself to better fit the data. Then comes testing. After training, you check if the model performs well on new, unseen data. This is important. A model that memorizes the training data but fails on new data is said to overfit. It learned too well, like a student who memorized answers but doesn't understand the concepts. We want models that generalize, meaning they can handle new situations intelligently. Let's break down another common scenario. Suppose you run a bakery and you want to predict how many croissants to bake each morning. You collect data over months, temperature, day of the week, past sales, local events. You feed this into a machine learning model and it starts spotting patterns. Maybe people buy more croissants on Fridays. Maybe rainy days mean fewer walk-ins. Over time, your model learns the rhythm of your business. Now you can reduce waste and meet demand more accurately. That's the practical power of machine learning. Now, here's something reassuring. You don't need to know advanced math or code to understand the basics. Sure, behind the scenes are things like regression, decision trees, and neural networks. But today is about intuition. The key idea is that machines improve by learning from data, not being explicitly told what to do. Still, you may wonder, how do we know which type of machine learning to use? The answer lies in your data. If you have labeled data, meaning you know the correct answers, use supervised learning. If your data has no labels and you want to discover structure or relationships, go with unsupervised. And if you're designing a system that learns by interacting with its environment, like a robot or a game AI, reinforcement learning is your go-to. Let's take a step back and reflect. Every time you unlock your phone with your face, sort spam from your inbox, get movie suggestions, or check the weather forecast, you're benefiting from machine learning. Systems because they continue learning. You might also hear about deep learning, which is a subset of machine learning. It uses artificial neural networks inspired by the human brain. Deep learning powers image recognition, voice assistance, and language translation. It's what allows systems like ChatGPT to understand and generate human-like text. But deep learning is essentially machine learning, just with more layers and complexity. We'll dive into that later, but for now, know that it's all part of the same family. So how can you start practicing what you've learned today? Begin by observing machine learning in your daily life. Notice how YouTube knows what you want to watch. Think about how Amazon recommends products. Pay attention to how autocorrect works. These aren't random guesses, they're the result of models trained on massive datasets. You can also try beginner-friendly tools like Teachable Machine by Google. It lets you train simple image, sound, or pose recognition models in your browser, no code required. Just upload a few samples, label them, and watch the machine learn in real time. It's a powerful way to make the abstract feel real. If you're curious about the algorithms, look into linear regression, k-nearest neighbors, decision trees, and clustering. These are the Lego bricks of machine learning. You don't need to master them all at once, but understanding their purpose gives you a big head start. Remember, today is not about becoming an expert. It's about building a mental model of how machines learn. You now understand that data is the fuel, algorithms are the engine, and predictions are the output. You understand that models get better with practice, just like people. And most importantly, you realize that machine learning isn't magic, it's a tool, a powerful one. The best part, you're only on day 3, and you've already started thinking like an AI engineer. Let that sink in for a second. You've stepped behind the curtain to see how intelligent systems are built. You've learned how machines learn by recognizing patterns, adapting, and improving. And you've done it without diving into equations or code.
Tomorrow, we'll explore something even more exciting, the tools and platforms used to build machine learning models. But for now, just let this lesson settle. Go back and rewatch any part you want to absorb more deeply. Play around with a simple ML app if you're feeling adventurous. And remember, understanding is far more important than memorizing. You're learning how to teach machines, and that might be the most powerful skill of the 21st century.